Hi guys, welcome back. This is the fourth episode of our DevOps learning series. Today we'll be discussing about continuous integrations. If you have missed any of our previous episodes, you can check out the link above. If you want to learn DevOps and get globally recognized certificates, you can check out our DevOps course. The link is given below in the description box. Let's start the video now. All right, let's talk about continuous integration. When we say continuous integration, which means that developers can make code changes continuously multiple times in a day. And how do we integrate the build and how do we generate that integrations, and then later you can use it. So there are multiple advantages of using continuous integration, and it is one kind of important things if we talk about DevOps. So let's talk about some key concepts of CI. I'll just name it as a CI, the short form of it, continuous integration. Okay. So the key concepts if I talk about, so one is the frequent integrations. Okay. Frequent integrations means that if somebody as a developer want to frequently make the changes in the code, and then they can push the changes to the code, GitHub repositories or any centralized repositories, Bitbucket or GitLab, they can do it. So CI let you leverage those facilities in the in form of making the code changes to the centralized repositories. So that is one key concept of it. Then another one is automated build. Automated build, which means that whenever you make any changes to the code, whenever you update the code, the build automatically gets created. So what is this build? Build is something, packaging of your code. So if you have seen in the real life scenarios or examples here, right? So you have downloaded any utility. So let's say if I download some tool, some software, so for that I need exe file. If I talk about Windows, if I use MacBook, I need .dmg file, or if I use Linux, I use .rpm file, or any Debian file. So that file is nothing but what? A package which has all the libraries inside it, which are very important to let the tool perform. So that's the reason in GitHub also, if you want to build some sort of a packaging, so that can be done via CI. So CI gives you functionality or opportunity to automatically builds based on the continuous changes that has been taken care to that repository. So that is what the advantages of using CI. Then there is one more thing called automated testing. So when I say automated testing, which means that let's say, for example, there are multiple engineers are making some changes in the code base. Who will check their testing is okay or not? Which means their code is fine or not? Because without doing a proper testing, if you push the code to the production environment, which means it will break things. It can break things, right? So we want to avoid those scenarios. So before going or letting any code to the production environment, before that itself we perform certain checks. So those checks are nothing but testing. That testing is automatically being automated. So that is kind of automation testing. Whenever you make any testing performed on the code which are being going live to the production environment, so that testing can also be happened via CI. So CI, this tool, I mean, it's not just like a tool, it's a process, process or a culture, right? Or a term you can just think like continuous integration. So this can leverage basically people who are developers and make changes on a day-to-day basis to the code repositories. It can validate their code. It can build the packaging, it can build the code, and then later, if they want to use the code, they can use the code, in the main production environment. So that's how any product is being developed with the help of CI. So this makes life easier for the DevOps people, because you don't have to do manual testing. You don't have to manually intervene, identify the breakage of the code or anything like that, right? So this can be automated. So that's the advantages of using CI in the picture. Nice. Now, if we see a few more, advantages in the sense of, so it can early detect the bugs. So let's say you have made some changes in the code which has some bugs. By looking at the code, you cannot identify the bug is there. But when you have some sort of a pre-checks, unit testing, or distributed testing. So those testings can let the code identify, it will scrub the code and it will identify, okay, there are some bugs into the code. So those bugs can be early detected rather than just going to the production and then later it will break the production environment. So that is advantages of being using CI, early bugs detection. So we can detect the bugs early. If I say this, early bug detection. Okay. Second one is collaboration improvement. So collaboration improvement means that let's say there are multiple engineers who are basically making changes to the same code base so they can collaborate to each other. We have seen in the previous session where developer A and developer B both wanted to make changes to the same code base. They have access to it and they are from the same team, but they are different people, so they can clone differently to their own repositories and then they can make the changes, right? So that make things easier to in order to collaborate also. So with the help of CI, it can let developers to collaborate more, so they can work as a team and build the product accordingly. Then they can talk about feedbacks. So when you have a single repositories centralized way and multiple people are using it and you are making some changes, so you can get the feedback from others as well, saying that there is some issue with this code, because everybody has the visibility to that code, right? So that is advantage. It's not like a silos where one team making some changes in the code, they are building the code or giving the packages to the another team and then they are deploying it, rather than they are just doing in the same platform where everybody has the visibility to see the code, to see the results of the testing, so that they can all on the same page identify there is no issues with the code, there is no bug with the code, so they can give feedback also. So this CI can let developers to have the feedback about if anything is going wrong, in the sense of, or this can be better improvised your code. So that feedback can also be given. That's another benefit of it. And then consistency and the reliability also, because this is the way you can be more consistent, you can be on a regular making the changes or check out the branches and then making the changes. Or reliability in the sense of, because we are purely sure about that this code will be running, there will not be any early bugs that is already being removed from this code, and then it will be live for the customer. So reliability can also be like trusted in the sense, because we have already implemented the CI. So now enough of with this theory, we'll directly jump on the demo. We'll see how do you build that CI basically, how do you build that continuous integration. So there are multiple tools to do that. One is Jenkins. People use Jenkins also, if they are good with the Jenkins and Groovy scripts and all. There is another one also, GitHub Actions. So we will see both. We will see how do you do it, the demo with the GitHub Actions. So let's start with the GitHub Actions first, and then we will see how do you do that. So for that, I will use my same account on the Ubuntu machine. Okay. This is my GitHub repo. If I talk about the GitHub Actions, so GitHub Actions are basically being present in my GitHub repository. Inside the repository, once you go inside the repository, you will see an action tab there. So this action tab is nothing but talks about the CI. This is all workflow. So it calls a workflow. If you want to create a new workflow, you can just click on the actions and then click on the workflow. It will let you choose, or it suggests what workflow is good for your repo, because see, every repository has some sort of a texture or speciality of particular code. So some repositories are mainly built based on the Java code, or some are based on the Go code or Python, or a number of languages, right? So they can have a similar way of integration actions, workflows, which can test their code, which can identify the early bugs. So accordingly, you can choose any packages or to perform the actions to your workflow. So you can choose any workflow. Let's say if I choose Anaconda workflow, if I have any packages testing on that, so I can choose this configure, and then it'll let me use it. Okay. If you have any other security related, so it gives you all kind of facilities where you can choose code QL or API stack team scanning. If you are doing some continuous integration for SLAS, security foundation related stuff generator, so you can use that. Or if you have some monitoring things on top of your code, so you can use Datadog synthetics. So there are like a lot of basically actions or workflows that can allow you to leverage in the GitHub Actions. So once that is done, so since I have already created two workflows for me, one is Python CI pipeline and another one is simple CI pipeline. So if I see here, how did I do that? I'll explain you that. For this, I go into my repository, which is my underscore project, and then go to .github. Okay, there will be a directory automatically present called workflows. So I go to workflows, and that's where my workflows are being defined. So if I create any new YAML file here, which will be in the YAML syntax indentation wise, this workflow will automatically being reflected here in my workflow section. So you can either create by the UI, or you can create by the CLI. That's what I did here. I just created a couple of YAML here, which are doing some actions. It can be any complex actions, whatever you would want to pursue. But I'm just using some basic actions to perform on my GitHub repo. All right. So let's see if I create this file, and I'll just let you see what is my content of Python CI pipeline. So if I say this, okay, so this is the content that I have in my Python CI pipeline. This is the name. Python CI pipeline is what you see on the GitHub as well. Okay. Now what it is doing is this action will perform on this condition. So there is this condition you have to provide actually. You don't have to remember this, how do you write the workflow file? You can just Google it up. You can get the documentations. How do you write the workflows for GitHub Actions? You will get the idea about syntax, about what are these, syntax means and stuff. I'm just explaining the way I've created here. So I am performing this workflow on if there is any push changes to my master branch. If so, this workflow will run. Or if I have any PR, any pull request somebody creates to the master branch, for the master branch, so it will automatically triggers this workflow. Okay, and what it does actually, so this job explains that below this, this will be builds. So this builds means it will create a package for the workflow, whatever it is performing basically. So this workflow job is running on some Ubuntu latest. It is internally choosing that machine to perform the checks, whatever it is doing. After that, it is checking out into the repositories. It is setting up a Python environment with version 3.10, and then later it is installing the pip for me, and then it is also choosing the requirements.txt. I'll show you what all this requirement.txt file will come from, and what is this. So this is nothing but majorly, if I talk about this workflow, is running this PyTest. So PyTest is an application which performs some unit tests on the any XML reports that you would want to let it perform. So this is what this workflow is doing. Okay, so if I see it up here, and if I let this go, so I'll show the architecture of this basically. So inside, if I go back, so you see here we have requirements.txt, which is the file this is using, requirements.txt. Okay, I'll show you what is this file contains. This has the requirement of PyTest, which is the application. Okay, so first it is downloading via pip for me in this pipeline. Okay, requirement.txt. After that, it has main.py. So if I show this, so this main.py, this is a main script. What it is doing is it is having a function called add, which is adding two arguments a and b, and then it is printing the value of those. Okay, and then there are some tests which are being written. Test.sample. This is where we are basically checking the test, using so this is another function called test_add. In this function we are checking 3 and 2. If we add both, it will be equals to 5. If yes, then this test will pass. Or this condition also, -1 + 1 is 0 and 0 0 is also 0. So this test will pass, then this action will be triggered as a completed. So this is what my workflow is doing. So see, this is one idea to create a workflow. It can be any complexity can be involved here, based on the use cases. There are multiple use cases. If you Google it up, what all use cases you can cover for the workflows. You can create an customizable whatever the requirement is. But I am showing here just an example. In this workflow, it's choosing an application Python, downloading the requirement.txt, which is having a PyTest as an application, and after that it is doing some additions to the functions and then identify the values are equals or not. So based on that, it is it will give me the values. It will work it. If it is succeeded, which means the addition functions are working as expected, they are giving the exact value whatever has been expected behavior. If it is not, then it will fail. And the trigger point is whenever you create any PR or you make any push changes to the master branch. So this is a trigger point when these jobs will be triggered. So this job can be manipulated, can be customized depending on the use cases. And I'm choosing here just to have a basic use case of a PyTest application to run the unit test on my report.xml, whatever the report I am getting based on based on my jobs that I am performing here. Okay. Perfect. So now if I see it here, and how do I trigger that? As you have seen before also in the actions, so there are 20 workflow has already been run before. So the last one is run 38 minutes ago. I'll showcase here to you one more time. Let me check. We will freshly trigger this workflow. I'll say git pull origin master. So let me just pull and fetch. Okay. So there have been multiple changes was done to the file himanshu.txt, which has been corrected now. I have to the latest of my head. Okay. This is good. Now let me add some more changes. Let's see. Go. Okay. Okay. Git status. Okay. So there were multiple files have been added here in this case. This is untracked file. Okay. This is another file that I have modified. So I am not sure about this file, what this file came from. Maybe I was trying to do some Kubernetes setup via Minikube. So I don't care about this file for now. I'll just focus on this file which has been modified. So I will add this file and I'll say commit modified txt. Okay. Since I am in the Git master branch, I'll say git push origin master. Okay. As soon as I push it, based on the definition of my workflow, it will automatically being triggered because this is the way it should supposed to. So if I refresh this, I see a new entry has automatically been created. So if I click here, this workflow has been triggered because if you remember the condition of this workflow, it says whenever you push to the repo or you are creating a pull request, at that time this workflow will be triggered. So this workflow has created and it has generated a build for me. Within 7 seconds it's able to generate a build. If I click on this build, you will see the definition of all the jobs that I have been provided in the workflow definition. So first of all, it will set up a job. Okay, it was choosing the operating system, which is Ubuntu. So all these settings is, if you remember, Python, if you remember here, it is choosing Python 3.10 and it is running on the Ubuntu machine. Okay. And with the Python, it is performing a PyTest. See, this is the Ubuntu latest. So whatever the latest machine of Ubuntu, which is 24.0.1, it is choosing that machine, and it is checking out to my Python library where I'll be executing some code. So after checking out, once it is checking out done, so it's checking out to my repository where I have made changes, which repositories have been updated the changes. So internally within this GitHub itself, it is basically doing some temporary changes in my home. This is the GitHub home directory for this user, and inside the temporary it has created some based on the commit ID or something. Okay, after that it has set up a Python v4, and it has installed the version successfully is 3.10.16. Once it does that, it is setting up the dependency. So this dependency has been already provided here in the workflow. Okay, this one, see, python -m pip install --upgrade pip. So this is what actually it is doing. So it is setting up the requirements for me, whatever the requirement that is there. So requirement has just file called pytest. So it has downloaded that pytest application. So here it says that successfully installed pytest as well, because pytest may need some dependencies. So these are the dependencies it has to also make it work. So once it does that, after that it is running a test. So this is the real test whatever we have provided here. If you look at the definition of the run test with pytest, you will see this is the test which has performed here, and this test is successfully completed. That's where we are able to see the definition later in the completed message. So it's cleaning up everything. So this means that this test application has been successfully completed, and then they were able to generate the the test file. Once that is done, this build is showing green, which means that it is able to successfully complete it. So this is how a pipeline basically being triggered. And if you create any PR also, this pipeline will be triggered, and then we will see that how do you make sure the integrity, or how do you make sure the early bugs detection, right? So let me do one more changes here. Let me go to git branch. Oh, it's not there. Okay. Okay, wait a minute. Check out git branch. Okay. Origin master. Git fetch -all. And then we will make some more changes. Let's say I will say today is Monday, anything. And if I say git status, git add, okay, git commit, I'll say updating himanshu.txt. Okay, then git push origin Himanshu. Okay, once I do that, and if I go to my code base and I go to pull request, create a new pull request from branch Himanshu. This is the new entry that I have added, and I create a PR. Okay, so once I create a PR, as per the definition of this action workflow, whenever you create a PR also, this will trigger. And you see here Python CI pipeline build has triggered, and it's in the queue. So it's starting the job, it is doing the actions whatever it's supposed to do. So this action can be customizable. This can be manipulated based on your use cases. In this scenario, I just wanted to showcase to you as a basic of it, that how do you create those actions? How do you create the workflows? Later, you can definitely, based on the use cases, you can customize it. You can just make it more complex. You can perform n number of testing based on the code that you are changing. But just to see how does it work is what I'm showing it up here. So see, this action has been completed successfully. Suppose that this action talks about some early detection of bugs. So if some unit test fails, instead of green tick here, you will be seeing some red marks, which means that something is going wrong with the with this merge, with this PR. So that can be kind of an identification to maintainer of this repo, saying that there is something which is not right about this code. So they can reject the PR, they can let the engineer work again and then make modifications whatever is required, and after that create a new PR. It will again run the same test as per the workflow definitions, and once that is done, it is able to make the changes and then create a build on top of it. So build is nothing but a packaging of the code base that you are basically using it, and let your client or whatever the product you have it, right? So that can be given as a build form, and that build can be used later for the consumers of your applications. So once all these workflows are done, then we can say merge completed, because we are sure about there are no issues, there are no errors in the workflows. So that is all completed successfully. Okay, so the merge is done, actions are perfectly fine, and then it's able to identify, okay, things were going good, so now it's able to merge the changes. Okay, if you can want to cancel it, you could have canceled it while it was running. The option was showing up here. So this was one when you create a pull request, when you updated it. So you can just check the code now in the code of your master branch, and these changes have been reflected here as well. So this is how you can create actions. Actually, I have one more actions. It's very simple, simple CI pipeline. This also I'll show it up here. Let me get CI old. So this is a simple CI pipeline workflow. What it does is, on the same, if there is any PR or any push request, this build will create a build on Ubuntu latest. It will just run a shell script. So see, if you want to make the customization or the changes I was talking about, so this is the section where you have to add those entries. You have to make the necessary changes or the testing that you would want to perform on your code, because that is how you will validate if the code is correct or not. So these actions, depending on the use cases, can be customizable. You can refer to the Google and you can just fetch whatever the code that you are writing, what could be the best actions for it to perform, so that the workflow can identify a reduction of the bugs. It can be more collaborative. So here in this case, it's just a simple shell scripting. So whenever you do any push or PR, the shell scripting will run, and then it will echo, print the value of it inside that local machine. It will create automatically, within the GitHub itself. It's not running on this Ubuntu machine, rather it's running on my GitHub workflow machine, where it is automatically creating a machine, and after that it is destroying a machine. So if I see it here, this also completed 2 minutes ago, because this pipeline also has a definition to trigger whenever there is any PR. So you see here, there was a PR actually when we merged the pull request. This build was created. It checked out the code. Okay, this was the code repository. It checked out the code, and after that, this will just run a simple shell scripting. Hello, this is a simple test of the workflow. So it was able to successfully make it run, and that's why this workflow is also completed. If the shell scripting, there were some issues, it might failed, in that case. And once if it is failed, then as a maintainer of the GitHub repo, you can be identify there is some issue. You can block that code merge, you can block the PR, you can reject it, you can just let the engineer rework on it, and then create a new PR. So this is how you can create a CI. This is what the CI means. It's a name. It's something, a process which you enable in order to protect the wrong code goes into your production environment. So which, it can be like any continuous, so n number of times if I do the continuous changes to my code, any, n number of times if I merging something, if I create a PR, this will automatically being triggered. This is kind of an automated way because I have already one setup. Once that is done, because after that I don't have to make any changes to it. So it will be based on any new changes will come up, it will automatically check those changes, that will run the scripts, whatever is necessary, the unit test, and once that is done successfully, later you can just anytime, any maintainer of the GitHub repo can approve the changes, and those changes will be pushed into the GitHub production environment. So this is how, via using GitHub Actions, you can basically use the CI in this form. Let's talk about demo of Jenkins as well, because Jenkins also, many of the companies are using Jenkins as well. There is also another tool to create a CI. So for Jenkins, I'll show it up here. So this is my AWS account. This is where I have created a particular instance. Any free tier, you can create a AWS account. It's freely available. You have to provide your debit card or credit card detail. It will just charge $1 at the beginning. Later, if you perform any compute actions on any virtual machines, then only it will be chargeable basis. Otherwise, you can just choose the free tier machines. Let's say I'm using here T2 free tier, micro, launching the instances. So that is why this is my instance type T2.micro, which is a freely available, and it will not be chargeable. So you can create your AWS account if you don't have it at this moment, because for the GitHub course in the future sessions also it may be required, because when we do Terraform also, you should have access to the AWS account so that you can make some changes. You can build your infrastructure accordingly, and you can destroy it. So I have created a instance which is a Ubuntu instance, and also I have I'll show it up to you. I have created a key pair as well. So this is my key pair, loading. Yeah, star agile hyphen AWS hyphen key. So this is the key I created the same way I showed up in the GitHub to create a SSH key pair, and I have this key pair available on my machine as well. I'll show it up to you. Just increase the font. Okay. Let me just wait. SSH, then star agile. So this is the key that I have created actually for my setup for this Jenkins. So to access the AWS. So this is the key, and based on that key, I was able to log into my Jenkins EC2 machine, and after that I followed the steps. So the steps you can get it on the Google itself. If you go to the jenkins.io. In the documentation, it will give you all the steps. How do you download Jenkins file? It's as simple as you are downloading any packages onto the Ubuntu machine using apt-get command, right? So similarly, you need a Java for that. So first you can download the Java, and then later you can download the Jenkins. So once you do that, the service is up and running. So as you can see here, my service is currently actively running, and this is the password it automatically gives whenever you first time create any Jenkins. Later you can change the password. It's up to you, whatever you would want to do. So here the prerequisite is that you need to have a AWS account. If you are not using any AWS account machine, you can locally deploy the Jenkins on your Ubuntu machine. Since I was having multiple complex machines here, and then I did not want to touch my environment here, so that's why I preferred to launch a EC2 instance on the AWS, and on top of it, I deployed a Jenkins machine. So I downloaded the Jenkins package and then start the service. Once I do that, the service was running up over here. So this is the public IP of my EC2 machine. So if I show it up here to you, instance, the basic things I'm just showing up. So this is my public IP of this machine, which means that it is a unique IP. Publicly, anybody can access this machine. Any services is running on this EC2 machine can be accessible from anywhere publicly, but depending on the security rule that you have set up for this machine, right? So I have set up a rule actually. So I'll show it up here to you. Not this one. Yeah. So this is basically having that any from anywhere in the world, I am able to access port 8080. That's where my Jenkins is currently running. So by default, whenever you download the Jenkins package and then you install it, it actually runs your application on the port 8080. And that's where it's listening also on my machine. So this is currently I am on my EC2 instance. So this IP address you are seeing here, 172.31.22.80. So that is nothing but the public IP address of my machine, but the private IP address of my machine. Okay, so on this machine 8080 port, with the help of public IP. So this is a public IP, and on port 8080, if I just go here and then refresh it, I can just see my Jenkins. So you can just re-log in again with the password. It basically either is stored inside where lib Jenkins secret, or it's being shown up when you see the service status. So Jenkins is ready. This is how later then I managed to download some plugins for GitHub, because I wanted to have a GitHub connections in order to make some pipeline to succeed. So this is the prerequisites for Jenkins setup. You should have an instance where you can just download the Jenkins package. You should have a Jenkins UI up and running. Once you log in, later you can go to the Jenkins pipeline, and you can then build your pipeline. So this pipeline is nothing but we saw in the GitHub Actions, right? So if you see here to our GitHub, so this is the same pipeline, Python CI pipeline and simple CI pipeline, but this feature is a GitHub feature. GitHub itself give that feature of creating the workflows, but in Jenkins you have to create a Jenkins pipeline. So if you look at the configuration of my pipeline, I just went here and then I made some changes in the configurations. So this is the script, what my Jenkins is doing. So currently I have set up an agent. It's checking the code to my GitHub repo. This is my project is my repository of GitHub. Okay, and I'm using credentials, GitHub -credentials. So this credentials I have set up in my Jenkins account. Okay, I'll show you where I've set up actually. You can Google it up. You can just find out what is the pipeline basic script or anything like that. Later, I'm just running a shell script here saying that hello Jenkins. So the actions, whatever you see here, it's as equivalent here, whatever we are seeing up here. So I'm just trying to, comparing things for you and making it easy to understand that how does the GitHub Actions look like, and how does the Jenkins CI pipeline configuration look like. So it's more like a similar functionality, but yeah, the syntax is different, the platform is different, the application is different. But the workflow, the idea behind it, it's same. It's doing the continuous integration. So it should have a connectivity. Jenkins should have a connectivity to your code to run. So whenever you make any changes, or you can manually create a build also, and then later it will identify if there is some changes to it, and then you can just see the output of those pipelines. So just wanted to give you an overview about how does a Jenkins UI look like, and how do you create a pipeline, and how do you create a connection, and then after that you can just build the pipeline. So this is basically running a simple shell script onto my GitHub repo. Okay, if I go back here and build now, if I do this build, if I click on this build now, you will see one more build will automatically being scheduled. So if I refresh this, yeah, so this is the build which is automatically scheduled and completed also. It's showing success. But if you go to the console output of it, you will see the step by step how does this build is being executed. So it's running the Jenkins on this pipeline. Okay, what it is doing is it is saying credentials not found, but later I think it is able to find the changes to the GitHub repo. Okay, it's able to fetch it up. Okay, all right. After that, once it does that, and after that it executes the script whatever we have been provided. So this script is automatically being executed on the Jenkins machine internally, and it says that okay, the script is running fine, there are no issues, which means that the pipeline is succeeded. It's as simple as what we did here in our GitHub Actions pipeline. So it is having a script just to check based on the push and pull PR, and then it is performing some actions, some jobs, whatever we provide, And once those jobs are being completely done, after that it says that okay, the workflow is successful. You can later make the changes, you can approve the changes. So similarly, if you have the connectivity to the Jenkins pipeline can automatically being triggered. You can make any configuration changes. So here I just have a basic one where it is just connecting to my GitHub repo, and if it is able to connect, then execute the script. You can have more complex, rather than just connecting. You can have whenever there is any PR happened, I want to perform some unit test on my Python code. If you have some Python library setup code base in your GitHub repo, so you can do that as well. So those things can be customizable, but the idea behind doing all these changes are same. You need to have the basic prereqs, and after that you can make changes whatever you would want to perform. Okay, and for the credentials, I was just showing up here. Manage Jenkins. You can just go to credentials. Okay, this is the GitHub credentials that I have created. So I'm using a PAT, which is a personal access token for the GitHub, to create as a secret for this. So has not been recorded as used anywhere. So it's good because it's not showing up as a user visible to me what is the PAT, but I'll show it to you. How did I create that actually? So you can also access via key pair as well, but in this case I just chose to perform based on PAT. This is another way of authenticating to the GitHub. So you go to the settings and go to developer settings. In developer settings, go to personal access token. So this is my personal access token I created for Jenkins specifically. And once it is shown, you have to copy paste it somewhere because it will be lost after that. It will not show it up again. So I created this PAT for me. And once that is done, here coming up here, I just added it, or if I want to make a changes, so later I can just provide the secret here. So currently it's concealed. It's good because it's not showing up to me on the UI. You have to update these credentials. So this way also you can use it, or you can create another way of setting up via key pair as well. So that is also option available in the Jenkins doc itself. You will get tutorials about how do you set up based on the access keys. But yeah, with PAT also you can set it up. So once that is done, and then you can just build the pipeline. So it's as easy to build it. So, and if you want to see the output of the pipeline, any changes, so it's good to go to any build and then go to the console output. So this is the console output, which is basically shows you what is happening to your pipeline. It's as equivalent to if I go back to my repo and go to actions and go to any pipeline and then click on this. So whatever the actions that you are seeing, the jobs it is performing here, so this build is as equivalent to the build here you see, the console output, what it is doing actually, what is this job is performing. So it's as equivalent. You can just think like that. Later you can just create a build out of it, and then you can just push that build to your GitHub, and then you can use the build. So Jenkins is another tool which people are using these days for the CI, but yeah, GitHub Actions is more preferable, I would say, because Jenkins have been using for a while, and GitHub Actions has been recently implemented, where it can give you more facilities, where within the GitHub workflows itself you can have multiple YAML files, and then you can set up workflows. But for Jenkins also you need another tool to go into and then set up all these things. So that is like another add-on to you. But depending on the use cases, whatever, it depends on which company and what kind of a product they have and what kind of an integrations they have with the tools and their culture of DevOps. Any chances? So there is no such hard and fast rule that you should always use GitHub Actions or you should always go for the Jenkins. So depending on the requirement and depending on the use cases of individual companies, you should have an understanding about, okay, how does the Jenkins look like, how does GitHub Actions look like, and how do you create the continuous integration so that you can achieve all the benefits whatever it surfaced through providing in order to make the code better, the code base better. So yeah, so this is about the CI in terms of overall picture in the DevOps portfolio. So you should have an understanding of this. Yeah. All right, thanks for watching. If you have got any questions and concerns, you can drop in the Discord channel. The link is attached in the description below. Till then, keep learning, keep smiling, keep growing.